In an extraordinary and unexpected development, NASA's James Webb Space Telescope has made a discovery that has left astronomers across the globe in awe. Just a few weeks ago, the telescope identified the earliest known galaxy in the universe. However, it has now made an even more remarkable finding, a supermassive black hole moving away from its host galaxy at an astounding speed of 4 million miles per hour. This discovery is unlike anything scientists anticipated, and it has generated significant discussion and speculation about its potential implications for our understanding of the universe. The James Webb Space Telescope, launched with the mission to explore some of the earliest stars and galaxies in the cosmos, has captured stunning images that provide a glimpse into the formation and eventual death of stars and galaxies. Webb's observations stretch back to a time just a few 100 million years after the Big Bang, when the first celestial bodies began to take shape. Yet this latest discovery, the behavior of this black hole, stands as a challenge to many of the scientific models that have been in place for decades. If you have an interest in staying updated on the latest developments in space and science, we encourage you to subscribe to our channel. Don't forget to like the video, share it to help spread the word, and activate the notification bell so you never miss out on new content. The unusual behavior of a supermassive black hole. The discovery of the supermassive black hole is creating quite a stir in the scientific community due to its highly unusual characteristics. Typically, black holes are regarded as cosmic entities with immense gravitational pull that draws in everything around them, including light. However, this particular black hole seems to be doing something quite unexpected. Instead of drawing in light and matter, it appears to be pushing them away and creating new stars along its wake. This phenomenon challenges the very foundation of what scientists have known about black holes, as it presents an entirely new way for these enigmatic objects to behave. What makes this even more remarkable is the scale of the effect. The trail of newborn stars that the black hole has created extends an incredible 200,000 light-years behind it, making this a truly extraordinary discovery. This observation is particularly puzzling, as it doesn't fit into the standard model of black hole activity. In response to these unusual findings, a team of researchers led by Yale University's Professor Peter Banda published a study in the astrophysical journal Letters, detailing the discovery and the potential scientific implications of this behavior. Further supporting these observations, NASA's Hubble Space Telescope has provided additional data, confirming that this black hole seems to be triggering the formation of new stars. The process occurs when the black hole interacts with surrounding gas, cooling it down and giving rise to the creation of new stellar bodies. This wake of newly formed stars behind the black hole is something that has never been seen before, and it raises many new questions about how black holes interact with their environment. The stunning galactic merger, ARP-220. The James Webb Space Telescope has also provided us with an incredibly detailed view of the ongoing galactic merger of ARP-220. This galactic collision is one of the brightest objects in the infrared spectrum, making it the perfect candidate for Webb's powerful observational capabilities. ARP-220 is located approximately 250 million light-years away in the constellation Serpens. It has earned its classification as an ultraluminous infrared galaxy due to its exceptional luminosity, which is over 1 trillion times that of the Sun, far surpassing. This spectacular galactic merger occurred roughly 700 million years ago when two spiral galaxies collided, setting off a tremendous wave of star formation. As a result, the merging galaxies formed a dense region that spans around 5,000 light-years and contains about 200 large star clusters. To put this into perspective, this region holds as much gas as the entire Milky Way galaxy, despite being a small fraction of its size. Previous observations made by radio telescopes had detected around 100 supernova remnants in a relatively small region of space, further emphasizing the extraordinary nature of this galactic collision. The James Webb Space Telescope's recent observations have shed new light on the intricate details of this merger, revealing faint tidal tails that extend from the edges of the merging galaxies. These tidal tails are the result of gravitational forces between the two galaxies, and they offer further insight into the dynamic interaction occurring between the colliding galaxies. Webb's infrared capabilities have also revealed streams of reddish and orange filaments of scattered organic materials in ARP 220, painting a stunning picture of the ongoing cosmic event. The discovery of primordial galaxies, perhaps one of the most astonishing revelations made by the James Webb Space Telescope, involves the confirmation of primordial galaxies located at the farthest reaches of the observable universe. These ancient galaxies, which formed just a few 100 million years after the Big Bang, were initially met with skepticism. Some scientists questioned whether these galaxies were truly as ancient as they appeared, or if they were simply nearby galaxies being mistaken for distant ones. However, after an in-depth analysis of the data, the telescope confirmed that these galaxies are indeed genuine. These galaxies, which existed when the universe was only 350 million years old, represent some of the oldest and most distant cosmic structures we've ever observed. Their light has traveled for more than 13.5 billion years to reach Earth, allowing us to peer into the very origins of the universe. This discovery is crucial for understanding how the first generations of galaxies came into existence and how quickly the universe evolved in its earliest stages. The James Webb Space Telescope's ability to detect extreme redshifts and observe in the infrared spectrum makes it uniquely equipped to study these ancient galaxies, providing a level of detail and clarity that was previously unimaginable. This breakthrough has allowed scientists to observe galaxies that existed at the very edge of the universe, offering vital insights into the processes that led to the formation of the first cosmic structures. Re-evaluating our understanding of the early universe, the discoveries made by the James Webb Space Telescope are causing scientists to reconsider some of the foundational theories that have guided our understanding of the universe. One of the most significant impacts of these findings is the challenge they pose to the Big Bang theory, which has long been the cornerstone of our cosmological models. Traditionally, it was believed that galaxies like the Milky Way took billions of years to form. However, the discovery of these massive primordial galaxies, some of which are up to 10 times larger than the Milky Way, raises important questions about how galaxies form and evolve. These massive galaxies, which appear to have formed just a few 100 million years after the Big Bang, defy our previous expectations. It was once thought that such large galaxies could not have existed so early in the universe's history. This new evidence suggests that we may be missing key pieces of the puzzle when it comes to understanding the formation of galaxies and the overall evolution of the universe. A new perspective on the Big Bang. This shift in our understanding of the universe has far-reaching implications. As theoretical physicist Michio Kaku points out, the discovery of such large, ancient galaxies forces scientists to reconsider what we know about the Big Bang and the subsequent formation of galaxies. If galaxies of this size could form so quickly after the Big Bang, it suggests that our models of cosmic